This is the most beautiful problem I've ever solved. This is a problem of limits. We have limit n goes to infinity of the product of gamma functions in all of this raised to 1 by n. So you can first let this limit as L. And now if we take log on both sides, exponent goes to product and sum goes to, sorry, product goes to sum, and that will be a lot simpler. We have ln of L as limit n goes to infinity, so this will come to a product, and this if we take log to this product, it will just log of product will be sum of logs. So that will be sum from I equals to 1 to n log of gamma I by n. Okay. So now that seems like a Riemann sum. Now, if you don't know what Riemann sum is actually a really easy concept. Let's say if we have this integral, you can evaluate this through a sum. So sum from I equals to 1 to n of f of a plus b minus a by n times I times b minus a by n. So this sum, when n goes to infinity, this will be equals to the integral. Now, in the much familiar terms, this is usually written as delta x, cause is the length of a single division, and yeah, this is actually delta x, and a plus I times delta x will be xi. So this whole term will be xi. So it's actually f of xi, which is the height, and delta x, which is the width. So it sums of all the small areas and gives the area of an integral. Now, if we know the Riemann sum, we can just compare with the original sum to find the values for a and b. So basically, we have delta x as b minus a by n, and we have 1 by n over here. For that, b should be equals to 1 and a should be equals to 0. And if we let this, our xi will be 0 plus 1 minus 0 by n times I. So that will be I by n, and that's what we have over here as well, f of I by n. Now, our f of x should be ln of gamma x. ln of gamma x, yeah, and that works. In that case, our Riemann sum will be just the integral, and the integral will be integral from 0 to 1, cos a is 0, b is 1, of f of x dx. f of x is ln of gamma x, and then dx. Okay. Now the next thing is to evaluate this integral of ln of gamma x. But we don't really know the function ln gamma x, the integral of this function. Okay, but we may not be able to find definite integral, but for finding, I pronounced wrong. We may not be able to find indefinite integral, but for definite integral, it can be found out using some ways. One of them can be like this. So let us suppose this integral as I, 0 to 1 of ln of gamma x dx. Now, if we use King's rule, so again, what's King's rule? So King's rule is something like this. If you have integral from a to b of f of x dx, this will actually be equals to integral from a to b of f of a plus b minus x dx. If you want to prove this, just take the antiderivative and try to see what happens. Yeah. Now this integral will also be equals to integral from 0 to 1 of ln of gamma of 0 plus 1 minus x, that's 1 minus x dx. Now if we add these two integrals, we will get 2i equals to integral from 0 to 1 of ln gamma x, and then plus ln of something. Now the sum of the ln's will be ln of the product of the two things. So this will be ln of gamma x times ln of gamma 1 minus x dx. Okay. Now we know that gamma x gamma 1 minus x has a formula. Yeah, and the formula is known as the reflection formula. And so from the reflection formula, we know that this is going to be pi by sine pi x. This is a reflection formula dx. Now you can break this into two logs. 2I equals to integral from 0 to 1 of ln pi minus ln sine of pi x dx. Now we will have 2I equals to, we can definitely evaluate the first integral since it's just a constant ln pi, so that will be ln pi dot x from 0 to 1 minus, for the second integral 0 to 1 of ln sine pi x, it might be a bit complicated. Okay, now we have 2I equals to, this will be ln of pi times x. So we will have ln of pi times 1 minus 0 and then minus. Now for this one, let us first try to uh, let pi x as x. Yeah, or let's say we can basically let it a different variable. Let's say we can also do it y, but I can do it also x. And so if we do that, we will have integral from 0 to pi of ln sine x, and dx will be, let's say if it was y, then it will have been pi times dx equals to dy. So that will be dy by pi. So that will be dx by pi. Yeah. And now 2I equals to ln pi minus 1 by pi of integral from 0 to pi ln sine x. Okay, now the integral of ln sine x, is symmetric from 0 to pi by 2 to pi by 2. Though this is not the graph of ln sine x, this is actually graph of sine x, but also it's not a graph of sine x, it's graph of cos x, I guess. But what I have to say is ln sine x will just be symmetric from 0 to pi by 2 to pi by 2 to pi. So why? Because in both of these domains, actually sin x will be positive and it will have the same values. So that's why you can also check the graph and sin x for further details. And now since that happens, we will have 2I equals to ln pi minus, that will be just 2 by pi of integral from 0 to pi by 2 of ln sin x dx. Now this one is a popular integral and the solution is well known, that it should be minus pi by 2 ln 2. But let's also try to do that in this video as well. Okay, so now for this integral, we actually know the answer in advance, that it's minus pi by 2 ln 2. We'll first try to find the answer with using this known information, and later we'll try to solve for this integral. So that will be plus ln 2. Now we will have 2I equals to ln of 2 pi. Yeah. Okay, now I equals to ln of 2 pi by 2. Now our I is actually this function. Yeah, this function. And this function is actually ln of the limit. So this one is actually not the answer. This one is actually ln of the required limit. Is ln 2 pi by 2. So limit will be actually equals to e to the power ln 2 pi by 2, and this will be e to the power ln gets 2 pi cancelled out and 1 by 2 as it is. So this limit is actually equals to root 2 pi. Yeah, this limit will be equals to root under 2 pi. Yeah, that's a beautiful answer. Now, if we want to solve this integral, that integral from 0 to pi by 2 of ln sin x, let's do that. So, integral from 0 to pi by 2 of ln sin x dx. So, if this integral is I, we can again use King's rule. So, this will be equals to integral from 0 to pi by 2 of ln of 0 plus pi by 2 minus sin x, that's just cos x dx. Now, you can add these two integrals to get integral from 0 to pi by 2 of ln sin x plus ln cos x, and the sum of ln's is just ln of product. So that's sin x cos x, which is sin 2x by 2 dx. Now our 2I will be integral from 0 to pi by 2 of ln sin 2x minus integral from 0 to pi by 2 of ln 2 dx. Now we can again change 2x to x, and then that gives us 2I equals to integral from 0 to pi ln of sin x and then that will be dx by 2, and then this will be ln2 dot x, ln2 dot x from 0 to pi by 2. So 2I will be equals to okay, now the integral from 0 to pi of ln sin x, and I have already told that integral from 0 to pi by 2 or pi by 2 to pi, both of them will be equal, so that can be, this can be 2 times integral from 0 to pi by 2, and the 2 and 2 cancels out, so this will be integral from 0 to pi by 2 of ln sin x dx minus this one is just pi by 2 ln 2. Yeah, now we know that this is the original integral I, so 2I equals to I minus pi by 2 ln 2. If we subtract this to other side, we get I as minus pi by 2 ln 2. So that's why we get this integral, and it's a popular integral. We found out the answer. Now this one is also complete, and the answer is just root 2 pi. I hope you enjoyed this integral, and if yes, do like, share and subscribe. Thanks for watching.